Hello everyone. Thank you for listening to my presentation. Today I want to present one of my papers titled False Relay Operation Attacks in Power System with High Renewables. As you know, with increasing the penetration of renewable energies into the power system, the inertia of the power system goes down. And this can make the change of the frequency to become faster. So, and also, as you know, the false data injection can happen on the DR measurements. So these measurements go to the control center, and then the control center sends wrong data, wrong commands to the governors, and then this change in the governor set points can change the power output of the synchronous generators. The whole story is happened like this. This change in the governor can make a load generation imbalance in the power system, and this imbalance can create actually some of the false relay operation in the power system. But in order to model this story, as you can see here, we are considering the change of the power in the system as a function of the change of the power resulting from governor change. Then this is the amount of the false data injection, and this is the amount of the load that can be shed from the power system, and this is the amount of the power that is actually the synchronous generator disconnection from the power system. And here we are modeling the governors and the discretized version of the governor operation formula, and here we are implementing the change in the frequency. And here we are assuming the load which is going to be shed by the load shedding relay because of the change in the frequency. And also this is the ROCOF value in the frequency in the power system, and this is actually trying to implement the disconnection of the synchronous generators because of the operation of ROCOF relays in the power system. After that, we implement the proposed formal method on a case study that has 5 buses and 3 synchronous generators. And as you can see, we have wind farms and solar panels also. So we considered different combinations of the parameters like R, T, A, D, H, and TOI. And we ran 10,000 different simulations based on these combinations that we have, but we only picked 2 of the combinations called C1 and C2, and we are giving the behavior of the ROCOF and frequency for these 2 case studies. The solver says that actually gives the result that if the attacker launches an attack of 0.322 per unit in case of C1 and an attack of the size of 1.015 per unit in case of C2, the ROCOF behavior and the frequency behavior of the power system would be as you can see in this table. But the only point here is that in the 12th discrete time step, the attacker is able to take the ROCOF value of the power system goes beyond the threshold in this paper, which is actually 0.5. This makes the ROCOF relay of the synchronous generator to operate and disconnect the generator from the power system. And here we are showing the result of the 10,000 different simulations that we ran in some of the graphs that we can see. As you can see here, the increase in the droop of the governors can and also increase in the inertia of the power system can lower the number of successful attacks, but an increase in the time constant of the governors and threshold of the injection, and also the number of attackable DERs, the increase in these parameters can increase the number of successful attacks of the power in the power system. And also in this table, you can see that if the inertia is less than 4, we have 2 different types of attack in the power system, which is ROCOF and load shedding. But when the inertia goes higher, the number of we don't have any kind of load shedding attacks anymore in the power system. So as the conclusion and future work of this paper, we showed that the inertia has the most impact on the reducing the success of false relay operation attacks in the power system, in a way that the higher the inertia of the power system, the lower the possibility of false relay operation attacks. And also we showed that an increase in the droop of the governor or decrease in the time constant of the governor can lower the possibility of false relay operation. And as the future work, we are going to consider a large scale system, and also we try to launch cascading attacks on the load measurements. Thank you so much for the time and your attention to my presentation.